Hi, everybody. Mr. Wyatt here, and today we are getting ready for the topic 7.5 assessment that we'll be taking tomorrow. And so here is your first video showing how to do some of these problems in today's review. So we have our first couple of questions were just vocabulary terms for our different geometry terms. Number one, what is the term for a part of a line with two endpoints and including all points in between? I could show it like this. I'll just use my line tool here just to make this a little bit neater. There we go. And I can draw in, for example, a figure that looks like this. And what you can see here is we have part of a line. It's not an entire line because it doesn't go forever in both directions. I don't see any arrows. It has two endpoints. Here's an endpoint right here. Here's an endpoint right here. Sometimes you'll see them labeled, like A and B, for example. And it includes all the points in between. Well, this is what's called a segment of a line. It's just a part of the line, and we call it a segment. A ray would be going forever in one direction. It would start at one endpoint, and then there would be an arrow pointing in one direction. A line would have arrows on both sides, and a plane, that's a flat surface that extends forever in all directions. So this is definitely not a plane. This is a segment. All right, number two. What is the term for lines that lie in different planes and are not intersecting and they're not parallel? Well, rays, perpendicular lines, and parallel lines all are on the same plane. Skew lines is the correct answer for this particular question. They lie in different planes. They are not intersecting. They are not parallel. I could demonstrate it kind of like this. I'm going to find myself a piece of paper that I'm not afraid to destroy here. And I'm going to use this piece of paper here to represent a flat surface that continues forever in all directions. Okay, think of this as being our plane. If you take a couple of lines, I'll represent it with this pen here and this pen here, and you lay them on this plane like this. I'll try to tip it so you can see it. These are parallel to each other. They run right alongside each other. They're always the same distance apart. Now, perpendicular means they intersect, forming 90-degree angles. Okay, these now would be sitting perpendicular to each other. A ray is different because that just extends forever in one direction. Skew lines, though, are not on the same plane, and I can show it like this. See what I have done here is I've stabbed this one pen right through, and then the other one is sitting on this plane, okay? So this one here that I'm wiggling here is on the plane. This other one here that I'm wiggling now is passing through that plane. It's on a different plane altogether. These will never intersect. They will never cross each other, but they're not parallel. They're not parallel because they aren't in the same plane. This is what we call skew lines, okay? All right, so skew lines. Number three, what type of angle is angle BOC? It might be helpful to trace the angle. Here's B, here's O, here's C. So angle BOC, we're talking about this angle right here. What type of angle is that? Well, what I notice is it certainly is less than 90 degrees. We have a 90-degree angle over here. Angle BOC is less than that. So that's what we call an acute angle. Obtuse angles are larger than 90 degrees. Right triangles are exactly 90 degrees, and you'll usually see a little square in the corner if it's a right triangle. And straight angles, those kind of look like lines, okay? Like angle AOD, for example, would be a straight angle. It's 180 degrees. Okay, but this one, angle BOC, is acute. In number four, what type of angle is angle FOC? Well, I'd better trace that. Here's F right here. Here's O. Here's C. Oh my goodness, they're in a straight path here. So angle FOC, it could be this angle right here. Honestly, it could be the angle underneath here too. I could show that in another color. This angle down here could also be considered angle FOC. It depends which direction you want to, which way you want to look at it. Either way, though, it's a straight angle because it's 180 degrees. It's half of a circle, okay? So that's called a straight angle, angle FOC. Angle AOD, angle AOD is also a straight angle in this figure. Number 5, which pair of lines are parallel? You know, when I look at this figure, there are only 2 lines that run parallel to each other. Line WX here and line YZ. Those 2 lines are parallel. I know they're parallel because see how this is forming a right angle here? And this one also is forming a right angle here. That's how I know those are running parallel to each other. Okay, we have a couple of transversals drawn in here as well. But WX and YZ are the 2 that run parallel to each other. And that's our first option right here, YZ and WX. All right, in number 6, what is the measurement of angle DCB? Angle DCB. Well, angle DCB is this angle right over here. I know that angle ACD is 79 degrees. So how could I find the angle measurement for angle DCB? Angle DCB equals some number of degrees. Well, what you'll notice is these 2 angles that are adjacent to each other here together are forming a straight line, line ACB. If you take this angle measurement, add it to this angle measurement here, it'll be 180 degrees. These are known as supplementary angles. Oops. Supplementary angles. They total 180 degrees, okay? So if you want to find this missing measurement here, just take 180 degrees and subtract 79 degrees from it, and the difference will be the measurement of angle DCB. And so we get 101 degrees. I can show myself making this 8 into a 7. This becomes 10. 10 minus 9 is 1. 7 minus 7 is 0, and then we have the 1 over here. So 101 is our answer. Angle DCB has to be 101 degrees. You can check this answer when you're done by just adding 79 degrees to it, and together they should add up to 180 degrees, and they do. So those are supplementary angles. In number 7, what is the measurement of angle X? Well, now if you look at this entire angle here, that's a right angle. It's 90 degrees. We know this part right here is 68 degrees. So what would this part here, represented by the variable x, what would it have to measure? Together they are 90 degrees. So you can take 90 degrees and you can subtract 68 degrees from it, and the difference will be that measurement of angle x. These are known as complementary angles. Complementary angles total 90 degrees. Supplementary angles total 180 degrees. So here I'm subtracting 68 from 90. And so I can make this 9 into an 8. This becomes 10. 10 minus 8 is 2. 8 minus 6 is 2. We find out that missing angle measurement has to be 22 degrees. I can check that as well. By the way, I could also say x equals 22 degrees. If you add 68 and 22 together, it had better total 90 degrees. And it will. If you add those together, it does equal 90 degrees. All right, number 8. So supplementary and complementary angles. Number 8, which of the following pair of angles are corresponding? We learned about different types of angles. We have vertical angles. If you think of that V here as being like an angle measurement, just extend these down this way, and you'll get a picture of what vertical angles look like. They're mirror images of each other. You see that? Like this angle here and this angle here would be congruent to each other. Those are vertical angles. We talked about corresponding angles. We talked about alternate interior angles as well. We also talked about adjacent angles, but those are a little bit different. Vertical, corresponding, and alternate interior angles are always congruent. Like vertical angles would be like angles 1 and 4, 2 and 3, 5 and 8, 6 and 7. Those are all vertical to each other. Corresponding are the ones that are in the same location within their different groupings of angles, like angle 1 and angle 5. See how they both are in the top left corner in their group of angles? They correspond to each other and they're congruent because of that. Okay. 3 and 7 are corresponding angles. 2 and 6 are corresponding. 4 and 8 are corresponding. So when I look at my options here, angles 2 and 6, that's the one I want to mark. Those are corresponding angles. Alternate interior. Interior means inside the parallel lines. Alternate means on alternate sides of this transversal. So 3 and 6, 4 and 5 are alternate interior. So 1 and 2 are actually adjacent angles. 5 and 8 are vertical angles. 2 and 6, those are corresponding. 4 and 5 are alternate interior. So you need to know all of those different terms as well. All right, number 9, same thing, but now we're looking to find the pair of angles that are alternate interior. Okay, 3 and 6 are alternate interior, 4 and 5 are alternate interior. And I do see 3 and 6, angle 3 and angle 6 right here. So I'm going to choose that one. 1 and 2 are right next to each other. They're not congruent. They're supplementary though. Those are adjacent angles. 5 and 8, they're right across that V from each other, right? Sharing that same vertex. Those are vertical angles. Remember, vertical doesn't mean up down. Vertical simply means they share the same vertex. They're mirror images of each other. And the 5 and 8 are sharing this vertex right here. 3 and 6, yeah, those are alternate interior. 1 and 5, those are corresponding. Okay, so there you go. 3 and 6 are the ones that are alternate interior. All right, number 10. Identify this triangle by the length of its sides. Well, if you're looking at the length of the sides, you have these options: scalene, isosceles, or equilateral. Acute and obtuse are ways to measure by the angle measurements. Okay, this time we're going by the side length. So we're down to 2 options here. It's either scalene or isosceles. Since none of the sides are equal in length, none of the sides are congruent, this is known as a scalene triangle. Isosceles triangles, you'd have 2 sides that would be congruent to each other. Okay, so this one's scalene. Number 11, identify this triangle by the length of its sides. And I'm noticing its sides are all the same length. See, they each have 1 mark on them showing they're all the same length. They're all equal. This is an equilateral triangle. Okay, it's also an acute triangle because all of the angles are less than 90 degrees. Okay, it is acute. But we're trying to identify it by the length of the sides, not by the measure of the angles. Okay, it's not isosceles because that would mean only 2 are congruent. And it's not scalene because scalene has none of them that are congruent. It's equilateral. All the sides are equal in length. All right, we'll continue on in the next video with numbers 12 through 20. I'll see you later.